Hello. Our group name is Crystal Math, and we will be covering basic counting principles for our discrete structures group assignment. Our group members are me, Izzah Camillia, Owen Sheffield, Boniface, Nurelia, and Ronnie. Moving on to the introduction. Basic counting principles are used to solve counting problems, but you might be wondering, what are counting problems? To explain that to you, counting problems are actually problems that require us to compute or calculate discrete events, which happen to be discontinuous or separate events. For example, there might be a situation with different outcomes, so discrete events are the separate possibilities of those outcomes. So, counting problems need us to calculate those separate possibilities or outcomes of that particular event. There are four types of basic counting principles, namely the product rule, sum rule, subtraction rule, and division rule.
Product rule. A producer can be broken down into a sequence of two tasks. There's an n1 ways to do the first task and n2 ways to do the second task. Then, task n1 and n2 can be done in n1 times n2 ways. How to answer question based on product rule examples. First, identify the event or variable that the question asks. Second, identify how many options of each event and variable needs. And lastly, after identifying all those information, basically just times or multiply it. For example, if there's a 4 boys and 3 girls, there's a 4 times 3 equals to 12. Different possible boy or girl couples. The boys and the girls are the variables, which is variable 1 is the boys and variable 2 is the girls. So 4 times 3 is equal to 12 is the different possible boy or girls couples. And for another examples, a student's ID is made up 3 uppercases letters followed by 2 digits. 3 uppercases letters is the first variable and the second variable is the 2 digits. How many possible ID is this? English alphabets it have 26, so basically just 26 times 26 times 26, and the 2 digits is the tens times tens. So in another ways, 26 to the power 3 times 10 to the power 2 equals to 1,757,600. Product rule in terms of sets. If A1, A2 until AM are finite sets, then the number of elements in the Cartesian product of these sets is the product of the number elements each sets. The task of choosing an element in the Cartesian products A1, A2 until AM is done by choosing an element in A1, an element in A2, and an element in AM. By the product rule, it's followed that A1 and 2 until all the way through AM is equal to A1 times A2 until AM.
Hello everyone, my name is Owen Sheffield, matric number 82901, and today I'm going to be presenting about one of the basic counting principles, which is the sum rule. So, what is the sum rule? Sum rule is if a task can be done either in one of n1 ways or in one of n2, where none of the set of n1 ways is the same as any of the n2 ways, then there are n1 plus n2 ways to do the task. As an exemplification, the mathematics department must choose either a student or a faculty member as a representative for a university committee. How many choices are there for this representative if there are 37 members of the mathematics faculty and 83 mathematics majors, and none of which are both a faculty member and a student? The solution by the sum rule states that if there are 37 plus 83, which equates to 120 possible ways to pick a representative, it's basically multiplying or summing up both 37 members of the mathematics faculty and the 83 members of the mathematics major. If you still do not understand, here's another example of the sum rule. There are 18 math majors and 325 computer science majors. So how many ways are there to pick one math major or one computer science major? The solution is, the total is 18 plus 325, which is 343 ways to pick one math major or one computer science major. The sum rule in terms of sets. The sum rule can also be phrased in terms of sets. A union B equals to A plus B as long as A and B are disjoint sets. Or more generally, you can refer to the equation below. Finally, The sum and product rule are normally combined when answering questions in discrete mathematics. For example, suppose statement labels in a programming language can be either a single letter or a letter followed by a digit. Find the number of possible labels. So the solution, once again, is to use the product rule, which is 26 plus 26 multiplied 10 equals to 286. As you can see, 26 plus 26 is the use of the sum rule, and then 26 times 10 is the product rule, getting 286 to solve the equation. Yeah, that is all for the sum rule. Thank you.
For the subtraction rule, if a task can be done either in one of n1 ways or in one of n2 ways, then the total number of the ways to do the task is n1 plus n2. Then n1 plus n2 minus the number of ways to do tasks that are common to the different ways. The next is counting bit string. For the example, how many bit string of length at either start with a 1 bit or end with a 2 bits 00. For the solution, use the subtraction rule. Firstly, we should put dotted line in at line. Secondly, just start with 1 bit, so we count the dotted line expect the line have a number, so it have a 7 dotted line. So it will be 2, 7 equal 128 ways. For the second is put the number of bit string of length at the end of bit 00. So we can see just now we start with a 1. So for this we end with bits 00. So it will be 26 equal 64 ways. Thirdly, number of bit string of length at let's start with a 1 bit and end with a bit 00. So we just put 1 at the first and 00 at the end. So we just count the line except the line have a number. So it will be 5 equal 32 ways. So just count 128 plus 64 minus 32 equals 160. Next is two finite sets. For example, in a discrete mathematics class, every student is a major of computer science and mathematics or BAF. So for A is a computer science major as major is 25. For B is the number of students having mathematics as a major in 13. And the number of students majoring in both computer science and mathematics is 8. So how many students in the class? So for the solution is 25 from computer science plus 13 from mathematics and minus 8 from student majoring computer science and mathematics. So the answer is 30.
Hi everyone, my name is Ronnie Atang, and today I will like to present to you a basic counting principle, and my part is division rule. In this part, I would like to you to explain to all of you about the rule of for divisions, three rules of division and three types for division rule. Rule for division. Basically, divisibility test or division rule in math helps one to check whether a number is divisible by another number without the actual method of a division. If a number is a completely divisible by another, then the quotient will be a whole number and the remainder will be zero. Basically, there are two concepts in division rule. First of all is three rule of division, and the one is three types of division. Okay, for the three rules of division, the last digit is even. For example, 0, 2, 4, 6, or 8. Sums the digit, the result must be visible by 3. Subtract the quantity of the digits 2, 5, and 8 in the number from the quantity of the digits 1, 4, and 7 is the number. the result must be divisible by 3. Okay, for the 3 types of division, the methods of division are of 3 types according to the difficulty level. These are the chunking method or division by repeated subtraction, short division method or bust-up method, and long division method.
I'm feeling hungry. I want to get some breakfast.
Oh, I know where to find food. Let's go.
Yeah, sure.
Wow, Camille. There's 2 types of food and 3 types of drinks. You can choose one.
Oh, so considering there's 2 types of food, a sandwich and a bun, or 3 types of drinks, chocolate drink, tea, and Nescafe, I guess I can pick 1 drink and 1 meal for my breakfast. So the amount of possibilities of my breakfast are 3 drinks times 2 meals. So that means I have 6 ways of having my breakfast. So
Wow.
you know what rule I used?
Is it product rule?
Yep, you're correct.
Wow, okay.
Then ultimately, can I have a chocolate drink and a sandwich for breakfast?
What?
Can I have a chocolate drink
Oh, yeah,
and a
sure,
sandwich
sure.
for breakfast?
Yes.
Okay. Thank you.
Thank you. So that's how we use the product rule in real life.
Thank you
Thank you for watching.
I should